Okay, so this is, I guess I called this example 2. This is kind of weirdly numbered. Sorry about that. All right, so example 2, I'm going to have you do these on Zoom, all 3 of those. So example 2, C, D, and E. Okay, so moving on to number 4 here. So when we're wanting to figure out how many ways to do a different operation, and there's k different steps, and each step has a different number of ways, then we just multiply all those numbers of ways together. So here I have a license plate that's going to have 4 letters and 3 digits. All right, so how many different plates are possible? So 4 letters, I'm going to have 26 letters of the alphabet 4 times, so 26 to the 4th, times 10 cubed, right? Because I'm just going to be multiplying for each of the 7 places, right? 3, 4, 5, 6, 7. A lot of times I'm going to draw these little spaces to figure out the choices I have for each of the spaces. Okay, so let's think about this one. So it begins with the letter A. So here begins with the letter A, and then 2, 3, 4, 5, 6. The last one ends with the number 0. So I don't have all the choices, right? I only have to pick these 5. So how many choices do I have? So I've got to have 4 letters. I've already got one of them here. So that means I only need 3 more letters, so 26 cubed. And then the number 0 is already chosen, so I only have to have 2 more digits, so that's going to be 10 squared. Okay, so how many license plates begin with TGIF? Well, I've already got my 4 letters, so all I need to pick is my 3 digits, so that's 10 cubed. All right, so then we get to a little more challenging one. So distinct, no repeats. No repeats. So that means 1, 2, 3, 4, 5, 6, 7. So if I have 26 choices for this one, then for the first letter, then, I'm going to let you figure this one out on your own. Okay, and then I'm going to let you figure this one out too. So think about the number of choices. After I pick the first letter, how many choices do I have left for the second letter, and the third letter, and the fourth letter, right? So these are all the letters, and then go figure out how many different choices you would have for the numbers so that they're different. There's not one repeated letter and not one repeated number. And I'll let you figure that one out too. All right, so kind of continuing on, just the numbers of choices. So we're picking an appetizer, an entree, and a dessert. So there's 4 appetizers, 8 entrees, 6 desserts. So it's going to be 4 times 8 times 6. So just number of choices chosen. So how many ways are there to choose from one boy and one girl that has 17 boys and 18 girls? So that's just 17 times 18, right? You could choose one of the 17 boys and then one of the 18 girls. Okay, so just making sure you get the idea. All right, now we're moving into different kinds of problems where we're working with numbers again. So how many integers are there between here, these two numbers? So just our counting, right? So and add 1. So this counts the number of numbers, including the beginning and the end point, right? So there's 9,000. Okay, so how many 4-digit odd integers? Okay, so this is where I want you to go and pick the hardest thing first. So the hardest thing is to make a 4-digit number odd, right? So what are the choices for the last digit to make it odd? So that's 1, 3, 5, 7, 9, right? So there's 5 choices to make it odd. Okay, so this digit would be the next most challenging, right? So pick the hardest one first, then go to the second most challenging. So the first digit, why do I have to worry about what I choose for the first digit? Well, I can't have 0 here, right? If I had 0 here, then it's not going to be a 4-digit number. So I want to say, well, all the different kinds of numbers. I can't choose 0, so there's 10 numbers total to choose, so I'm not choosing 0, so there's 9. And then I'm going to be choosing the others. So these 2 digits here have no restrictions on them, right? Because I've got it odd, I made it 4 digits, so there's 10 choices here and 10 choices here. So that this number multiplied, and I want you to leave it like this, is the number of 4-digit odd integers. All right. How about 4-digit odd integers with distinct digits? Ooh, okay, I want you to do this one. And 4-digit odd integers with distinct digits. Okay, I'm going to have you do that one as well. And then I'm going to have you do this one. I'm making you do a lot of them, huh? Okay. So number 8 here. How many integers from 1 to 1,000 have distinct digits? Okay, so I'm going to help you do this one because I want you to be sure that you're thinking about 1-digit numbers, 2-digit numbers, 3-digit numbers, and 4-digit numbers, right? So there's OR, so that I have 1-digit numbers, or 2-digit numbers, or, right, so it's plus. Anytime you think of OR, 3-digit numbers, or 4, right? So the 1 4-digit number I have is 1,000, right? Okay, so how many distinct digit 1-digit numbers do I have? Well, 9 of them, right? 0 through 9. Okay, or. So now I've got 2 places, right? So I've got this and this. Okay, so this is where it gets tricky. This is where you have to always think about, okay, I can't have 0 here, right? So I've got only 9 choices for this digit. Okay, so then how many choices will I have left for this digit? Well, whatever I chose here, I can't use here, correct? So I have 9 choices for that digit. All right, moving on to my 3-digit number. Again, I can't have 0, right? Not 0 here. And whatever I chose here, I can't use here, so there's 9 choices there. I've chosen 2 numbers already, so I only have 8 choices for the next one. So there it is. That's how many integers from 1 to 1,000 have distinct digits. And I'm going to let you do this one.